So I'm really happy to be here. And this will be the GNU Radio technical update about what I've been doing to the code for the last, let's say, more than half a year, and where we'll be going soon. So what will happen in the next 40 minutes is we probably get picture back. And in the meantime, what I'll do is have a short rundown of what was the state of the GNU Radio scheduler for the last 5 years, of GNU Radio for the last 5 years, what has happened since I started maintaining the project, what will happen soon, and also what will happen not so soon, but definitely soon enough that we'll still be around to see. And finally, I have like some final remarks, and I intentionally kept this a bit short so that we can have actually like a bit of Q&A in the end. So let me dive right in, and let me shortly introduce myself. So I'm Markus Müller. I'm the project maintainer, which means that basically all your code contributions go over my desk. I look at them, I nitpick, and then it gets merged usually. So why am I here? Well, I'm Ethos paid my flight and my hotel room. So thanks you guys. I do work for Ethos as support contractor. So that's one of the roles that I have here. Also, I'm a research assistant at the Communications Engineering Lab at the Karlsruhe Institute of Technology, for Technology. I mean, the German doesn't really translate as well. Which is the University of Karlsruhe, really. What I do there is I do the exercises in probability theory and communication theory and some other smaller courses, which basically means, yeah, I get paid to nerd around. That's pretty nice. Then I also have other hats. I do the occasional seminar. I help people for money, and that's what I do. But most importantly, of course, I'm here because I'm the maintainer. So welcome to my talk. Yeah, just for future references, you get the presentations all online. So whatever you want to talk to me about, I won't be upset if you contact me on the wrong address, but those are my contact details. Let me jump right into where has GNU Radio been. So we've been stuck with GNU Radio 3.7 for 5 years by now, which is not, we're not really stuck. It's been a fine and nice project. And as you can see here, there's an infinite void of things that happened. When we, 3.7.0 was released in 2013. That was kind of a big thing, as it totally threw away the old APIs. So basically, all C++ programs had to be at least ported, let's say. It was compatible in thought. Just the naming was completely different. And even Python programs didn't work because the namespacing had changed. So that was kind of a big change back then. And I remember that it took us quite a while, let's say, until late 2014, and until most popular applications weren't 3.6.5 anymore, but 3.7 compatible. So I've put down these lines to signify how long a certain release was the current release. And as you can see, we used to have 2 months, 3 months, 4 months occasionally recycles, and then later on development slowed down back here. I'll explain in a minute how that happened and why that's not a good thing and how is that not bad now. But why it doesn't get faster here? Well, I took over as the GNU Radio maintainer in early February of this year. And the first thing I did was basically sit down with Martin and look over the existing pull requests and get release out, basically, so that we can start again. So this is where I am. And the current release is 3.7.13.4. I'm pretty happy with that release, actually. There's not many bugs in that I know of. There are some. But this has been obviously a rather mature branch of development. I mean, the fact alone that there's a 13 in front of here basically says, OK, we've stuck to the same idea, the same API at large for 5 years. And it should be pretty mature by now. So mature also means it has some set structures. And those were basically defined by how we used to do the GNU Radio development. So this is all Git, right? So we have different branches. We have the master branch, which is, for most projects, and including GNU Radio, the main development branch. We do have a main branch, main for maintenance, where like it used to be that this branch was where like bug fixes were merged into. So we had the development branch, the master branch. We had a main branch that basically got all the bug fixes, and obviously you wanted bug fixes in the development branch too. So we always like merged back main, then continued main, merged back main into master. So that's a pretty common way of developing projects, it has a lot of upsides because you don't have to like do bug fixes twice. You don't have to bug fix something on master and then on the version that you give to the people that want like a stable release. It has the downside that basically main defines when master is ready for a release. Of course, in that model, you need something else to prepare for the infinite void for future releases. And that's the next branch that's getting forked off, and it was meant to be 3.8 at some time. That's what happened here. This next branch was merged, branched off actually pretty soon after we released 3.7, and it's been we'll release that soon branch for like 4 years around now. But what does this mean? Like, what happened is that Next basically was able to like change dependencies, be like progressive, and master wasn't. So that meant that everyone who wanted to work on an innovative GNU Radio release had to work on Next, which was perpetually broken, which is OK, it's a development branch, right? And everyone that wanted like feature that he can use right now in their application had to go for master or main. That basically meant that, well, Next was somewhere else. It was nowhere close to be mergeable. And master was not able to like incorporate new ideas because those had to happen on Next because that had like all the access to newer versions of dependencies, could change some things that master couldn't. So that led to a situation where basically development was slowing down because, well, we had like the split between people that could actually add features without having to care about breaking the past, and people who actually had to like have working GNU Radio for their day job. So that was like kind of a bad thing. But then I took over, I had a long talk with like guys like Martin and Mo and whatever, and we basically decided, well, let's change that. First thing that I did was introduce major semantic versioning, which you might know is basically a 4-point thing for GNU Radio. Has a major, which traditionally is 3, and we are probably not going to change that very soon. But the idea is that if you like change your paradigms, you change that. Minor remains OK. This is the way the API works. The API actually says, OK, if you can recompile your library, your GNU Radio library, and you have a program that links against that, and the API number didn't change between, then that program just doesn't even have to be relinked because it's really like the same program, the same functions, just what the functions do inside might have changed, might have seen a bug fix, but there's nothing removed or changed in behavior that breaks existing binaries. So that's very nice. And just to be able to count the number of things we did, we have this last number, the patch level. So the idea is that this allows me to push out releases rather quickly without people having to be afraid that I break their application without them noticing because, well, you can see. If I don't change the ABI number, you'll be fine. Your program will still continue to run. If I don't break the minor, which is the 7 for this release, then, well, recompiling your program will work without headaches. So the idea was that this allowed me to rapidly iterate over applications. I do hope that maintainers of distribution packets, and I'd like to point at Mate here, who's basically been an influence there with his Debian packaging. That makes things easier for them because they can go in and say, OK, we've got this new GNU release coming out this week. I can package that, build it, and rebuild, if necessary, anything else, because I can actually trust the versioning to represent the fact whether the things are compatible or not. So what I also did is formalize the changelog format. So if you feel like that, go into the source tree right now, look into the changelog. It's very strictly categorized and things changed, added, removed, bugs fixed, that kind of thing. So this hopefully helps at researching when things break in the future, which never happens, as anyone knows. Then I said, OK, I don't want that I take main and merge it back all the time model. Simply because, well, what my job is fostering development and at the same time keeping my releases reliable. So what I'll have is, OK, we have a 3.7 release series, right? So this is not where the exciting stuff happens. This is what people use that have an existing application that works with the current version of GNU Radio. So whatever I'm going to do to a 3.7 release has to be primarily compatible and an improvement, but not a revolution of what's in there. So there's now our main 3.7 point branch, which is only meant to bug fix, slightly modify things that don't change anything about how the project works. We'll get rid of the next branch, which is actually happening. Well, I can't say right now because obviously I'm staged, not at my computer. But next, which has been fragmented all over the place because, as I said, 4 years of development, people trying out different things, having to work their things. There were a large number of branches. We got that back into a single next branch, which took a lot of work and encouragement. And actually, people like Andre have been immensely helpful to me in that. So I can't stress how much I'm not a single person maintainer, but someone who's been involved with great people that helped me get things out the door. As soon as Next is merged, I have something that I can actually call a technology preview. That's how 3.8 will look and feel, right? There will be a metric ton of bugs in there, and that's not fine, but it's the way it's going to be. We're doing development, we're breaking things, we're progressing. But as soon as that Next is merged into master, we can take a technology preview, and later on this year, probably even this month, we'll take 3.8, which is exciting because it gives us a lot of freedom to actually break with compatibility with ancient operating systems and this kind of things, and also allows us to use cool new feature, which I would address in a minute. So that all means that, well, there's no merge back model anymore. You will submit your bug reports and your bug fixes to master, which is fine. It's my job to take these bug fixes and put them on the main 3.7 branch if I want that bug to be fixed on 3.7, which I probably will. That takes a bit of work off your shoulders onto mine. And I'm OK with that because it's actually easier for me to look at every bug and every comment individually and say, OK, this is something that breaks things. I don't want to have that on 3.7. And this is something that, without or with slight modification, can and should be applied to 3.7. So we can have a very stable 3.7, which is the standard version for 5 years. So people will be very, very dependent on that, not changing much. and we'll, at the same time, focus development on a single branch so that people don't have to run off again and do something on a vague future. This will be sometimes a release branch, or at least that's what I hope. So let me quickly address what will happen through the 3.7 series. So as said, that's been like the standard for 5 years now. I can't, even if I wanted to, I couldn't let it die because the project would just fork, right? People would say, okay, I've got this application, I've got this satellite network that runs on 3.7. I'm not going to use 3.8 tomorrow, so could you please not let that die? And promise, I'm not going to let that die for like a rather long time. So 3.7 has a future, and we'll not let it die. What we'll not do, and I mean this very seriously, I'll not invest much time into making 3.7 work with whatever, Ubuntu 22.04. Because that's not, if you need to have like the bleeding edge operating system in the future, well, then you'll have either to have forward port your GNU Radio to that future version of your operating system, or you'll have to port your application forwards to the current version of GNU Radio at that point. This is not because I don't like people or I don't like applications. I do. It's just because, keeping the balance between forward development and keeping things reliable says, okay, we're at a point in time where people can actually run containers with operating systems at a specific version in them with no performance penalty, so we don't have to keep old versions updated to new operating systems forever. But there's a lot of operating systems that do behave rather stably. I've put Debian Stable on there, although it's one of the most progressive, it's probably the most progressive among these operating systems, but it's been known to work for a long time. So if you're running CentOS or the current LTS version of Ubuntu, then you'll probably be fine for a while. We have CI in place to actually check we're not breaking things. And when we do, we'll fix them. And only after we fix them, we'll take a release. So your operating system will not package something that breaks the application. But please be prepared that 3.7 has to go in the next couple of years. So that's the time scale we're talking about. What we'll not do is introduce cool new features into 3.7. Again, this is not because I don't like developers or applications or companies. It's just because I need to focus on something, and also I can't break things. And not breaking things is really important for users of 3.7. So there will be no C++ 11 and 3.7 in the future. There will be no Python 3 support. There will be no Qt6. There will be no whatever. But this doesn't mean that 3.7 is obsolete today. Keep that in mind. So let me talk about more exciting stuff, why I'm actually excited to be here. So this is, as I said, we've been stuck with 3.7 for 5 years, and it's about time. No? So what we did in 3.8 was foremost realize that, if you depend on the same kind of library for 5 years, the world moves on. So we had to change in some aspects because people wouldn't package us anymore, wouldn't deliver GNU Radio into the infinite void anymore because the dependencies simply weren't there anymore. We do have problems with old C++ versions, old Python versions too. So there's a progression to cooler, newer programming languages, and we already see the advantage of that in the scheduler. We do have a cleanup on dependencies. We removed a few components. We added new functionality. Let me go into detail there. So first of all, Python 2 is dead as a doornail. Someone's clapping. I like that. So Python 2 has been a great programming language, but even Python themselves say, OK, we stopped supporting that, I think, around 2020. So distributions actually are stopping to ship Python 2 by default at this point, which means we have no choice here. We have to have a Python 3 support in there or look for a different kind of scripting language, which I don't want to. So, OK, we have Python 2 out of the way. Qt4, it's been around longer than I've been around software, which is not that short. So Qt4 is dead, and I think Debian already stopped shipping that. Gentoo still does, but on Gentoo you build everything yourself, so you're basically on your own anyway. Then we've got Cheetah, which is a Python 2 library only. Well, obviously we can't use that to implement our templating for code generation either. And what I'm most happy about is that Ubuntu 14.04 is not longer a system that we need to support, because that's been a nightmare for everyone involved so far, because it always, like, Canonical has a great way of picking dependency versions. And yeah, Ubuntu 14.04 was a beacon of broken boost. So with these dependencies removed, we had to move to Python 3. We had to move to Qt5, and actually those, the Python 3 move obviously was a big one, and we're still working out the kinks on all that. But the Qt5 merge was obviously rather okay. You see, Debian actually made the progress. Mate's laughing there. Like Debian, in the person of Mate, actually backported the Qt5 thing to 3.7 because he had to, because Debian would stop shipping the GNU Radio packages because they had a dependency that couldn't be met within the Debian ecosystem. So these are the two big things in terms of dependency deprecation. But as said, we had to move to Python 3. So there was a long discussion whether we should continue to support Python 2 in GNU Radio 3.8. And so that's the point where I'm a bit hesitant to say that we did the right thing. It's not bad what happened, but what did happen is that we said, okay, for at least a couple of sometime we need to support both, because we can't break all our ecosystem, right? So because if you break the ecosystem, you end up in the infinite void. So what we did is we guaranteed Python 2 and Python 3 support, which means we have to support 2 versions of Python, and that's obviously increasing complexity of fixing things. So we do still support Python 2. We don't support the ancient Python 2.6 and 2.5 that GNU Radio 3.7 used to support. The Python 2 support will be gone with the next minor release. So 3.9 will no longer support Python 2. But we kind of see GNU Radio 3.8 as the golden bridge to get there for people that have an OOT module to actually forward port their things to something that doesn't break everything at once. Things you can still run your unit tests, and that's immensely helpful if you forward porting software is always, if the last thing that breaks is your unit tests, well, porting gets a lot easier. So I'm happy about that, but it does mean more work. And everyone who's been involved with Swig knows that having another language in Swig is not fun. Then we have something that I'm really excited about, is C++11. That makes a lot of things a lot easier for us, because we don't have to depend on Boost for a lot of core functionality. Our smart pointers are supplied by C++11 by now. Everyone who's writing a loop that goes over elements in a vector doesn't have to use for index blah, 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 or Boost for each, and then arbitrary breakage, because that's just an ugly macro. There's standard for each, and that actually works pretty well. We have lambdas, which make a lot of math operations easier to write, easier to understand, less prone to breaking. And that's something that I even like more about C++11. We have simple constructs that, if you say this is a pointer, and you then have to cast it to int just to set it to null, it breaks the whole type safety thing. And having const expressions allows us to check whether things can be compiled to a constant value, or if we hit some state in there that can only be determined at runtime. So that's been a great thing, and I'm really happy about C++11 because it looks so much nicer. I didn't put this on a slide because that's usually what scares people. We'll do a complete code reformatting for 3.8.
Everyone who knows GNU Radio Scheduler or core code knows that it has the most, let's say, it has a high diversity in white spacing, which is an interesting thing to have, and it's not very desirable. So that's something that's been overdue forever, and many projects are very hesitant to have a giant commit in there that touches every single file, because it kind of breaks git log if you look into and git blame to figure out who and when something was changed in a way that broke things. But on the other hand, tools have gotten better, and you can just I press B in my editor and just shows me the prior change and who did that, and I can show that people. So that's fine. So yeah, that's the way we'll deal with source code in the future. Then, of course, I said deprecating dependencies. A new release, a minor release, also allows us to move forward in terms of dependencies. I didn't put the versions on there by purpose, actually. These are in the CMake files, and if you build GNU Radio, you get a documentation file that says which version is OK, which minimal versions of these dependencies is OK. But basically what that means, we can use modern CMake. We can use a swig that's not as old and as we used to. We don't have to support boost 1.39. That's all fine. We can actually use the things that are in the current releases of the long-term supported Linux distributions. Mac ports is rather progressive. Windows is a whole different world. Everyone who's using Windows is using some source build where they all collect their dependencies themselves. So they actually aren't dependent on old versions, as long as they're available for Windows at all, which brings me to GMP. So we've had a long outstanding logical issue in GNU Radio, which is that if you have a resampler with a rational ratio, this rational ratio is communicated to the scheduler, used to be communicated to the scheduler by means of a floating point number. And whoever knows floating point numbers knows that 7/13 is not really a good floating point number. So there has to be some rational math in there. And that basically means that we need something that actually does the division well for large integers. And that's how the GNU numeric library comes in for large precisions. But that doesn't have a Windows port. Well, we can't break Windows completely. Luckily, there's a fork of GMP, the MPIR. And if you're on Windows, you'll have to use that. If you're on Linux, you use that. If you're on Mac, you ask Michael Dickens. That's how it works. We have Qt5 now, which is a large dependency. It's way larger than any other dependency in terms of installation size. But it does work easily for most people, so this is not a great thing. And among others, I'm just highlighting this one because people will probably, this will be the first thing that people notice. We moved out code that used to be included in its entirety in the source tree, mainly vocoders, and which was codec 2 and libgsm. These are available by now for Linux, for decades in Linux operating systems. They're easily installable on Windows. So instead of including that source code in our source tree and have non-updated versions forever, we took these and put them into external dependencies, and we're fine with that so far. It's actually not changing anything. It's just removing the source code from the tree and saying, OK, we need that somewhere else. But with progress always comes change. So we're letting WXGUI die. In fact, it's been rather stiff for a long time because, well, I'm not aware of anyone who's able and willing to maintain that. It has a lot of bugs. On many machines that I've actually worked on, it just doesn't show anything. And we don't know how to fix that. I don't know how to fix that, and honestly, I really don't know who would. So since we do have Qt-GUI and it does the same thing, we're deprecating that. We've been deprecating that for years now, and we're actually letting it die with 3.8. It is not the case that WXGUI already has reached feature equality. So that's something that I want to stress. We do have a bug issue in a bug tracker that tracks all the differences that we still have to fix. But for all like practical purposes, most people will be fine using Qt GUI, will be using much less CPU, and will actually get something that I can tell them how to fix if something breaks. So I hope this is a winning situation. We simply can't continue supporting that. Well, we also threw out GRCon18. For those who don't know, Comedy is like an interface to commercial control systems. I've never met one of these devices, nor did I ever meet a user of these devices, nor did we see any changes to that code tree in like 10 years. So it probably doesn't matter to anyone anymore. So we're letting that die. Something that kind of like made me wonder whether we actually should be doing that is we're letting the Funcube dongle support in tree move out of tree. So I'm removing it from the tree. Not because I don't like Funcube dongles again. They're fine to receive from the infinite void. But these are the only things in GNU that depend on like actual hardware interfacing libraries. So that's not an easy dependency to have, and it should work just as well as an out-of-tree module. There's a limited number of people that depend on it, so that was something that I'm willing to like spin off because I can't test it myself, but I'm not willing to let it die in the ecosystem. So this is something that we need to figure out how to like rate that as an external and internal project. That's something that we need to actually like work out with the community on that. Then we have a couple of application-specific modules. It's a little bit like confusing that GR-ATSC is in there because that's just a digital TV mode and it's still existing in the tree, just somewhere else. But NOAA and GR-Pager have been removed because these are very like application-specific. I do like these modules, but they like are too application-specific and have too few tests for me to guarantee that they still work. So if someone comes up to me and says, hey, I've got this great test suite for GA-NOAA, and actually includes an NOAA decoder in tree because that's not even there, I'm very happy to like make this work again. But for now, it'll not be in the tree for much longer. But let us talk about something more happy here. And aside from the Qt5 and Python 3 things, which are new functionality, to be honest, we do have new things in there. First of all, Swapnil has been a student who's been working with us with the GSOC, Google Summer of Code program this year. So Google paid him to work for us, which is like a very nice thing to do for Google. And we thought we could have him here, but that's not happening due to visa restrictions. He actually bought a flight, he applied for everything, and it was just denied. So he can't be here today, but he overhauled the GR module tool, which is just like if you've ever written a blog, you've probably used that. It generates all the stubs that you can use to like put in your functionality and be done with it. And it's been much better now. It has a nice CLI, fixes a lot of corner cases. It's been great. So and that will be in there. And the other big thing, like there's a lot of things that happen on Next, but I'm just highlighting things. And this is something that many users will notice, is that GRC has changed. Not so much on the surface. You see a few things like blocks might look a little sharper, nicer to the eye, but under the surface there's a lot of interesting change happening. So we've got this whole thing is no longer based on PyGTK, which is like deprecated and isn't packaged anymore. It's now based on G-objects. That took a lot of work. It also included like restructuring a lot of the GRC code, and I'm especially thankful for Sebastian Kozlowski over there, who's been having like a blast doing all that work. And I'm really like, this is a lot of work. GRC is actually like most probably the most prolific GUI tool for the design of SDR systems in the world, and we're really not giving this like enough of applause. This has been like a solid overhaul of what's happening in there, and now GRC is really easier to write code for in most parts. There's a lot of things to do, But, well, Sebastian went in there and made it possible to do things without having to hope that nothing else breaks on the complete other end of the code base. As said, we had to replace the Cheetah templating engine with like Marco or simply static string. So this is a nice touch because, as said, Cheetah has not been especially nice a dependency to us. And what's really exciting to me is that finally, last year's Google Summer of Code project, which was GRCon doing C++ code generation out of flow graphs, has been merged in. And that happened, and that's something that I mentioned earlier, that happened in a branch based off Next. Because, as said, like if you're doing innovative work, you couldn't work off master because that's been stagnant for so long. So we're happy that this actually happens now. I'm really sorry for GRCon that it took us like literally years to get this entry, but it'll happen soon. So in a few weeks, you'll be able to just click on Generate C++ in GRC and get something that you can actually put somewhere, compile, and have something that you can run without even having Python installed on that machine. Like, I know that doesn't sound as exciting to people who think that, you know, if I have GRC, which is a Python program running on my machine, then I have Python. But if you're an embedded developer, chances are you don't want to install Python 3. And so that makes a lot of things a lot easier. That branch that GRCon worked off also contains important change to the overall way that GRC keeps its block definitions and its descriptions of how flow graphs look. And we're moving away from XML to YAML, which makes the whole thing a lot more compact, easier to read, hopefully, easier to write if you have to go in there and fix something manually. So this is something that's probably a big progress for anyone who's actually writing their own blocks and having to specify parameters for their blocks on their own. So I'm really happy that this happened too. So with that being said, well, this is all happening in 3.8. And what's happening after we've released 3.8? Like, obviously, GNU Radio is then finished. We have nothing to do anymore. We go, and everyone who's excited about development moves off to Red Hawk. Except that's exactly not what we're going to do. We're going to look at the things that we'll have to change in the future. And this is more of a brainstorming thing. So that's actually intentional that I cut off here. Just there's too much to put on that slide. But like ordered by the order of things happening to my brain, there's still a lot of things in GNU Radio that aren't properly tested. We can't tell whether something changes. Something changing actually breaks something. So we have to fight the bit rot there. First of all, that means that we need to have more unit tests. That's very simple. Like, there's a lot of functionality where you can actually say, I put in this, I should be getting that. And that test simply is missing from our test suites. And that's not a good thing. What's also missing is a lot of integration testing. Like, actually, we've got most of the tests the wrong way around. Most of our unit tests are actually integration tests. They test whether something works in a larger context. For example, we have basically very few scheduler tests, unit tests. We have a lot of scheduler integration tests because we connect this to that block, run the flow graph, and it works, so the scheduler has to work. But that's like a very high-level thing. It's just like it says, OK, this immensely complex thing works, so all the parts probably work too. That's not a unit test. That's an integration test, actually. So we need to focus on understanding where things could break and actually testing that. And understanding is an important topic here because I've been having excellent talks yesterday and the weeks before about how the scheduler works and how the scheduler should work. And truth be told, there's a lot about the scheduler that's just grown organically, which is not a bad thing per se. But if you look at the code base, you notice that a lot of features have been added on and then bolted on there. And that basically means that we have no formal specification of what happens when you run a flow graph. And that's not a good thing, because if you have no formal specification, nothing to tell people, to communicate, OK, we can't merge your change, or you can merge your change as long as you documented that in that way, then there's no way to like clearly communicate how to move forward with how the schedule works without knowing what will break or what will not break. And so we need to understand the scheduler. Then, of course, we'll have that running problem of dependency progressions. Okay, that's something that I've talked a lot about today. But especially, what I want to highlight here is actually the core scheduling mechanism is our thread per block scheduler, which also has been around for a very, very long time. And it's a pretty clever concept. You basically take each block gets its own thread. Each block waits until there's some input data, checks then whether there's enough output space, computes whatever it can compute, writes it to the output space, notifies its neighbors. And why both neighbors? Well, the downstream neighbor has to know that there's no input. The upstream neighbor needs to know, OK, I've consumed something from your output buffer. You can use that for new output now. So that might change the fact that the upstream neighbor was blocked by a lack of output buffer space. So that's something that's pretty clever, and it basically hands off all the scheduling problem to the operating system. And operating system people are traditionally rather smart about operating systems. So scheduling is an operating system problem. That's fine with us. But, well, it's not really like the optimum case, because the operating system has no idea whatsoever what we are doing with data, right? It just gets the info like, hey, this thread wants to wake up. Could you schedule that? And then it does. Or it doesn't, and it does that on some CPU core, not another one. Maybe not the one that's close to the actual data, like hasn't got the data in its cache, and we're starting to transfer a few kilobyte over to a completely different CPU core, although that block only does a multiplication with a factor of 2, and then writes that to the RAM, and somewhere else the next thread gets spawned, and the copying takes 100 times as long, as much time as the actual computation. So that's happening. Actually, we actually see that in real-world performances, and even things like saying, OK, these 3 consecutive blocks should be running on the same CPU, not informing anyone of the order of things or who to schedule, with what priority or anything. That's been proven to actually increase performance by 18% or something. So that's so low-hanging fruit there. That we need to address that sooner or later, and I'd rather address that sooner. So also, yesterday I had a rather interesting talk that Christopher gave. Basically, if you hit some roadblock number of threads, your scheduling overhead, basically just the communications of, hey, I'm ready, yeah, I'm not ready, kills, overshadows the actual workload, and then we're running into serious problems there. So the thread per block scheduler scales well, but it doesn't scale infinitely. But, and I want to highlight that, there will be a work group that actually talks about how to make GNU Radio work on platforms where not everything is the same CPU core. It'll happen on Friday, and please come there if you're an expert on this topic. And I think there's a lot of experts in here. And argue with me about that. I have some fixed ideas, and I should probably be shouted at that I don't do anything stupid. So please come and discuss this with me. Then there's this thing that when I said we removed GRNOAA, that hurt my soul. OK, that hurt my soul very much, because that actually removed something that people could relate to. They could receive weather imagery from satellites with that. And that's a cool application, obviously. That shows you how to do things with GNU Radio. Well, it did. It was written a long time ago. It doesn't reflect all the modern paradigms of GNU Radio and how to use that. And obviously, we need to have golden ways for people to follow, to copy, to apply to their own problems. Because there's a difference between having a very well-defined DSP problem and having to design a system. And with GNU Radio, we're a long time past the point where the primary problem is implementing DSP algorithms. We're at the point where the actual problem is building a system. So we need to show people how to build systems, how to write the code that works well, is understandable, is maintainable. And we don't have enough examples of how to do that. We have a lot of examples. Those are old. Some of them are actually bad practices by now. So we have to tidy that up, and we mainly need new ones. So then we have, to solve a lot of legacy problems, we have this serialization library in 3 that is neither serializing well, nor is it portable, nor does it have any language bindings aside from languages that we already support, nor is it respects endianness or some newish concepts that we didn't think of. So that's something that we need to replace, and that's a lot of work, but it needs to be done sooner or later. So there's a lot of things to solve for GNU Radio 3.9, 3.10, 4.0, I don't know. We don't have a roadmap right now when to break things fundamentally or not. So this will be something that we will define as soon as we figure out how 3.8 gets adopted, what the problem with that are. And I can only invite you to actually come and shout at me again, because I will do stupid things that break your applications at some point, and I don't want that to happen, so I'd rather be shouted at than have users leave to other projects because I broke GNU Radio. So with that thing said, let me shortly conclude this. So we've picked up momentum with 3.7 again, which is fine, but 3.7 has reached a level of maturity that we can't progress innovatively with that, so we have to release 3.8, which is happening very soon. It has all the new cool features that you want to have, so start porting your software now. You can have the next branch right now. Best case, wait until we had made the merge and try it. We need a lot of bug reports, please. And we'll have to release 3.9 rather soon, also to start overcoming our technical debt and make GNU Radio work for the next 20 years and be the greatest thing in software-defined radio since sliced bread. So that said, let's hope you have a lot of questions.
Thank you, Marcus. All right, do we have questions from the audience? No? Sam? All right, here we go.
So this is for the general users, the non-developer users of GNU Radio, right? So you're going to be implementing 3.8 soon. How can we help? What's the best thing we can do if we submit bugs? How should we submit them to you? How can we make sure that, with our limited knowledge of development in some cases, how can we make sure to help improve this?
So actually, I'm really thankful for that question. So what will actually help is, when I merge, on some people's machines, random things will stop working, right? So I've got developers complaining all day, which is fine. I'd like to highlight Sylvain there, who's been doing a great job at complaining. So actually, we need bug reports. So start GNU Radio Companion, click together your demo applications, your FM's a receiver, and report how well that works.
So just to clarify, though, Sam as a user of GNU Radio, she's not going to be on the same code base that you're talking about, though, right?
Exactly. So that's something that we should have said earlier. What we'll do is have packages so that you can go in there and install that without compiling the whole shebang yourself.
It's like a GNU Radio unstable. Testing? Tech
awesome,
demo?
GNU Radio, awesome, next, whatever.
Okay.
Next, so something like that. Tech preview packages that you can actually install and try and tell us where it broke your computer and deleted all your files. So that's something that I'd actually be very, very, very thankful for, every single bug report. And don't be oh, I don't know how to describe the problem. Make a screenshot, make a drawing, send me a letter, whatever. I really just want to know what broke. That's the whole point. Could you have the microphone? Oh.
Where do I submit bug reports?
So that's a good question. Actually, we do have this issue tracker on GitHub. So github.com/GNU Radio, one word, small letters, /GNU Radio /issues. It's actually where to send in things. If you're not sure how to send in things there, just write me an email, write an email to the mailing list. At this point, we don't care about formalities. We never did, honestly. Just send in an email.
This might be a good time to highlight. We have a workshop on filing and fixing bugs.
Yeah, that's an exciting workshop that I totally already did all the slides for.
When is that workshop, Marcus?
It is on Thursday, I think.
Okay.
I hope.
So you mentioned Python 3 being something an embedded developer might not want to bring in. Another killer is Boost and Qt. Do you envision versions where, for 3.8, where there's a subset that uses the C++11 and doesn't rely on Boost at all, or is that too far in the future at this point?
So actually, like in the scheduler, we could do that because, like I said, like all the pointers can be handled natively right now, and that's like the main thing. So I don't think we can actually build without Boost completely now at this point. But it's like Volk has been replacing Boost, for example. Like Nathan has been very hard at work there to get rid of Boost because that's like an ugly dependency, right? It's not impossible. It's not just on my agenda very high because in the end, most like blocks do use Boost in some manner. So removing that from the scheduler doesn't solve the overall problem very quickly. So yeah, it's not high on my priority list, but I have this nagging thought that maybe we should get rid of Boost.
All right, Tom?
Yeah.
Hi, you mentioned about integration and reproducibility. If you can kind of dig into some of the efforts that you have on that. And then for the dependencies, that's something I'm very interested in, so let's talk afterwards.
Okay, yeah, that's like I didn't get the first part of your question. Could you please repeat, sorry?
You mentioned about some of the work being done for integration tests and reproducibility. So if you can kind of address a little bit of that and what kind of help you need for that.
So reproducibility is like a big thing for us. We need to have like reproducible builds to actually like guarantee that what we've built and works here will work over there too, because it's going to be the exact same thing. So and like we've reached that state actually, like with a lot of help. Again, Mate has been tremendously helpful there. We are at a point where we can like fix the binaries, so that's fine. Unit testing, like integration testing. So we've got a lot of things like we have things that are called unit tests that, for example, test the whole OFDM receiver chain that we have in GR Digital, and that's a great example of a test that fails, and we don't know why. So that's probably not a unit test because we don't know what breaks, and a unit test will always point out at the exact unit that breaks. But what breaks is definitely not a single block. It's a combination of blocks. So it's good that we have that test because it shows us that there's something wrong here. Something doesn't quite like interact well. But it doesn't show us where exactly that is. So I don't actually have an answer for the question what to do there. Basically go in there and write unit tests. Basically go in there and write, like specify behavior. And as soon as you know what your behavior should be, write an integration test that respects that. So that's something hard to actually answer. Let's talk. I mean, yeah.
Yeah, let me just add a few comments. As the Debian packager, you're looking at moving dependencies. I've been working with the Debian distribution, coming up on the next stable release. It's been a shifting sand of constantly increasing C++ versions, new Boost versions, and as part of my building package in the Debian infrastructure, I'm starting to see how these underlying dependencies shift, how they need recompiles to keep from breaking APIs. So I've been running ABI compliance checker, make sure the packages are going. Debian has really good tooling for that. I think we're in a really good shape to get 3.8 to be something that will work. So some of that's sort of testing, builds, testing, and so I do run, the Debian build infrastructure does run make tests, so anything that has a unit test that CTest does and CMake, that's important to maybe add to that because the Debian infrastructure will run that on all architectures and do a lot of debugging for you as maybe new C compiler versions come up, and we'll get benefits from that. So I think that's awesome.
For anyone who doesn't know, by the way, this is Maitland Bottoms, who's part of the Debian project and does all of the Debian packaging for GNU Radio. So if you've ever apt-get installed anything and it worked, you have him to thank. Yeah.